那个第二排也把它关掉好了，让存在上第二排。Okay, let's look at e-learning system. As I mentioned before, we are going to have a midterm next week, right? So please try to catch up, and the coverage is going to be from陈理，这笔不是没电，它这个是不稳定的，因为它就打不出来。可能不是电池的问题了，那应该是本身它大家接触不了。因为昨天也是这一次。Okay, next week we are going to have midterm exam, and it's closed book just like quick, alright? And the coverage is going to be from unit 0 to unit 3, including the lecture file for supplemental about start time and hold time dating. I try to get some lecture slide that will help you to understand the start time and hold time before we mention it. And so please download the file unit 1-1 about timing. And today we are also finished unit 3. That's why that's the coverage. There are 4 lecture slide unit, including the supplemental about start time and hold time, right?
会发考卷吗？
你可以去。
会发考卷。
对，and also I'm going to give you back the quick exam. You can look over the grading, and you have to turn it back, all right? Otherwise, you are not going to have score for the quiz. And if any question, you can discuss with the TA, and if there's any dispute, you can come to me, come to see me, right? Not now, but near the end of the class, I'll give you back the quiz. 就课程快结束的时候才给大家看一下。你先上课。First of all, as I mentioned, we have some lecture page on start time and hold time. Before, we have already discussed that, but I think it would be better to give you some figures to understand the detail. The timing for sequential network, actually you can also call that sequential circuit. The register or flip-flop and also some conventional circuit, they are connected together in the network. How we should analyze the timing to make sure that the circuit can really work. This is a typical D flip-flop, and the clock signal, and D input, the Q output, the Q bar. So the critical issue about the timing of this kind of flip-flop or register, if there are more than one bit, like 2 bit, 4 bit, 8 bit, 20 bit, that's registered, but the idea is the same. The timing requirement about start time and hold time constraint, that we are going to talk about right now. Just to refresh. As I mentioned, when the signal coming out from this register or this flip-flop, they are going to go through the conventional circuit and arrive at the input of the next stage, next flip-flop register. It's also triggered by the clock signal. So a typical sequential network looks like this, having both conventional circuit and flip-flop. Any questions so far? So do you remember what is start time and what is hold time? Do you still remember that? What's the definition of start time and the definition of hold time? Let's look at the figure first. Look at this figure. The clock signal goes from low to high at the time point of the writing age. The data at the input is going to get into the latch, and after some delay, it will appear at the output. That's a typical flip-flop or typical register behavior. But we require that your data input should arrive before the clock age, okay? And this with the time amount before the start time. Or we should say that, we can say that the D input has to arrive before this time point, because we have start time for this flip-flop. This is the characteristic of this flip-flop. The input has to arrive before this time. Otherwise, you are not guaranteed to get the correct value in the flip-flop. Furthermore, your data input, the input flip-flop, they should not disappear. They should not be overwritten before we have enough hold time. In other words, D has to stay right there, even though the write occurred. It should stay right there at least so much time. That's called hold time. Otherwise, you may encounter hold time failure, and it does not guarantee that you can get a correct value at the flip-flop, in the flip-flop. Okay, let me repeat it. This figure shows that the definition of start time and hold time for this flip-flop. This flip-flop is triggered by the clock signal writing age. This is the timeline, which is critical, because the data input should arrive earlier than by this timeline. It could be earlier, fine. It could be on time, no problem, but it cannot be later than this timeline. Or that's what we call that set time. You have to set up the input before the age. And also, the same data input should stay right there. You cannot take it away. You should not remove it. You should not override it, because it has to stay right there at least so much time. That's hold time. The data input signal has to meet the requirement of both the start time and hold time to guarantee that you can get a correct value in the flip-flop. And this next light signal, meaning your signal can be up and down, any value, it doesn't matter. But after that timeline, they have to be fixed, stable. Okay? Keeps so much time. Okay? After that, you can change, no problem. So far so good for the definition, right? 这个定义名词都清楚了吗？什么叫 set time， 什么叫 hold time？ 意思就是说，你只要 input 必须在这个时间点之前就一定要到达，可以更早没有关系，可以准时到达没有关系，你不能晚于它才到达，因为晚于它到达的话，它这边就有一些不定的讯号出现在这边，那是不可以的，它必须有足够的 set time。 hold time 是你知道一样要撑在那边，不可以立刻消失。等到 edge 上去之后，还要停留一段时间，之后你可以任意改变没有关系，可是不能够比它之前就改变回讯号值，否则不保证你可以抓到正确的值。Okay. Now, why this is important? Because we have the timing constraint in these two equations.这是笔吗？那个，另外有一支笔吗？还是这支笔而已？
另外一支在电脑下面那边。
这支吗？我抽出来的。
这支又是在这里的。
有这是抽出来的，是应该还有一支笔。
没有，那支是这里的。对，那支这里的。
没有另外一支吗？
另外一支是这里。那支是我刚从那拿出来的。
不是，这我刚抽出来的。
真的吗？
好，先不管，我等下交给谁？So, okay. So that's a definition of start time and hold time. And your design of the circuit should meet the requirement of the start time and hold time such that there's no start time failure or no hold time failure. And the equation would be like these two for start time and hold time respectively. Let's look at the first equation. What does it mean? It says that, okay, TCQ, the definition of TCQ, clock to Q delay. Remember that term? Clock to Q delay. From the clock signal at arrival to the time you get the output at the Q. That's clock to Q delay. TCQ the clock to Q delay. COK Q delay. Meaning how much is spent, how much it needs for the clock signal to the output appearing. How long is it? The clock Q delay. That delay plot T-com. T-com is the conventional circuit delay. Well, actually, there could be more than one signal path in a conventional circuit. And when we say delay, it means that the longest delay. Some signal might appear. There could be more than one signal, right? Input and output, there could be more than one signal. Some signal might appear earlier, some signal might appear later, okay, for the conventional circuit. And we should consider the longest delay, the source signal coming out in the output. That is the conventional delay, propagation delay. Okay? Plot T setup, the setup time of this flip-flop. The sum should be less than or equal to T. T is the clock period. Clock period meaning that the amount of time you can have signal going through this stage is set. Okay. The clock cycle time can be longer than that, okay, greater than or equal to, but it should not be less than the sum of these three delay. Why is that? Because when the clock signal arrives, the starting point, clock to Q delay, this delay is the first component. Second component is the delay going through the computer circuit here. And the third component is the setup time. You should be arriving earlier than the clock edge and need so much time, that's setup time. So that equation should be less than or equal to T clock period. Is that clear? In other words, if you are considering setup time, this setup time, you can move these two to the right hand side, and that will be T minus T CQ minus T clock. And the T start time should be less than or equal to that amount of time to meet the start time criteria. Or you just remember this equation should be adequate, should be okay. Just remember that your clock period should be either greater than or equal to these three delay. The first one, clock to Q. The second one, conventional delay, longest delay. And the third one is the start time of this lever, and that's the start time requirement. Is that clear? How about hold time? Hold time also should meet some timing requirement. I did not talk about this before, but let's look at this equation. It says that hold time should be less than TCQ plus T conventional delay. But this time, the conventional delay is not long path, but a short path. These two are not really equivalent. Okay, if only one signal, they are the same. If there's only one signal going through a conventional circuit, then these two are the same. But if there are more than one signal, like we have three signals coming out, and four signals coming out, three signals come in, four signals coming out. The longest delay is the signal path. That is the longest propagation delay. The shortest path is the shortest delay for the signal going through. Okay? And these two could be different if there are more than one signal wire. Let me give you just an example. Example, if there are three signals coming in and two signals coming out, and it goes through a NAND gate, and then combine with it with a NOR gate, for example. Let's do this example. Inside the conventional circuit, the NAND gate, the NOR gate. And we can see that the signal coming out and the output of the conventional circuit, they are not having the same delay. Is that clear? Which one is earlier coming out? There are two signals. Which one will get the value earlier than the other one? The up signal, right? In the top. Because it only goes through one NAND gate. However, for the second output, including the NAND gate, you have to add the NOR gate delay. So that signal will arrive later than this signal. So in this circuit, this is the shortest delay, shortest path. This is the longest delay, longest path. So when you consider start time, you are considering longest delay here. Because your clock period has to be covering all these delay such that the signal is set. Okay. So that is longest delay here. But for this equation, it is shortest path, shortest delay, because we are talking about whole time constraint. And it's about your data arriving and our input on this flip-flop. They should be right there, staying for some amount of time before the new value will override the data, the value. So this delay should not be too short, otherwise it could override the signal waiting right here. So in this case, we are considering the shortest delay. The whole time should be less than, or we can say that clock to Q plot T, this clock to Q delay, okay, plus the shortest delay in the common circuit. The delay should not be too short, otherwise it could catch up the old value in here, such that it's not going to have enough whole time. Let me repeat it. This equation is talking about whole time constraint, whole time requirement. These two delay components should be greater than whole time for this flip-flop, because clock to Q delay, clock here until your signal coming out, plus the delay through the common circuit, we are considering shortest delay, because if it is longer delay, should be even safer. Shortest delay, they could catch up, they could override the old value waiting in input on this flip-flop. And that delay, the total delay, should be greater than whole time. Less than that, no problem. I'm sorry, it has to be greater than that. Less than that, then we'll catch up with the old value, and you don't have enough whole time for the flip-flop. Okay? Would that be clear? 这样听得懂吗？能不能 repeat it? 没能 repeat。这边讲我们的一般的电路系统的设计，它含有 sequential circuit 的时候，这 flip-flop 或者是 register 都可以是 clock 去控制它的 timing 的，它必须要满足 start time 的 requirement 跟 hold time 的 requirement 或者 constraint。那主要是这两个关系是要能够满足它，否则我们电路不保证可以 work。第一个是说我的 clock to Q delay 是从你 clock edge 到达之后，经过一点 delay 的时间，它出现在 output 端，它不就 TCQ 吗？加上我需要经过走电路的 delay， 我们要取最长的 delay， 因为你要考虑的是我要让它 clock size 足够可以 cover 所有的一个讯号的流动时间，再加上 start time 是它比我下一个 edge 到达的时间更早就要到达的那个时间叫 start time。整个加起来必须小于它的 clock period， 它的周期，因为它周期必须够宽够大，能够涵盖这些 delay， 使得它不至于不够，它会不够。那第二说 hold time 部分，它必须小于这两个东西的和，因为你的 clock to Q 的 delay 加上这边是取最小的 delay， shortest path delay， 这两个 delay 呢不可以太短，使得说我讯号edge 到达之后，我讯号出来，又马上通过它去盖过去之前，等待在这个 flip-flop 的 input 端准备要进去了，或者说它 hold time， 它还不够 hold time 的时候，我就赶上它，把它改掉了，那这样就电路就错掉了。所以它的 hold time， 说这两个值必须要够大，要大于它的 hold time， 让它不会下一波的资料很快就赶上它，把它 盖过去，使得后它们不够。这是这两个要求的 constraint。Okay, any question? Yes.
那个 T code 在这张图上是哪一段？
如果我们看刚刚讲那个这个图，我们第一次它的就讯号传递那个输出线，对不对？它呢要比 clock edge 或者下一个 clock edge 到达之前要先到达，至少要这么长的时间。之后它又要再撑一段时间，主要就是因为我们担心 we are worried about that the next wave 下一波 next wave of the data override the previous value waiting at the input of the next flip flop。就我们要担心的是，你如果说我的后趟我的这个 delay 太短的话 ，clock to Q delay 是这一段嘛，对不对？再加上这边的 delay 是指的是比较短的 delay， 它不够长，使得说我一出现资料就盖过去前一波的资料了吗？那盖过前一波资料，就使得它在等待在 flip flop 的后趟不够。这个如果不够大的话，那么它就会盖过去，它就使得我这边等待在门口的后趟不够，因为它被更改掉 value。也就是说，我刚刚那个图里面，你要不能太快被盖过去新的值，你太早新的值进来之后，我就有可能这边值就已经产生变化了，那这样就代表后趟不够，因为下一波值已经赶上来了。
所以这张图的话，那个 hold time 就有点像是那个 clock to Q 的 delay 加 combination 的那个值是吗？就是它的最小限制。
这个是吗？
对，就是它的线刚刚画出来的那一段，是可以是这个意思吗？
我们就看这个电路图 ，look at this circuit. Clock to delay, this is the clock cycle, right? The clock cycle, clock period, and starting from this time point， 这个时间点 ，clock edge arrived, and after some delay, the output appear, right? This is clock to Q， 这是 CTQ， 这个时间，对不对？那这段时间再加上我通过主流电路的 delay， 是 T-count， and we take shortest path, not longest path， 因为我们担心是它 delay 不够，所以我们要用取最坏的一个情况 ，worst case， so the quicker， this is the shortest delay. These two delay, the sum of the delay should not be, should be greater than your whole time amount. Otherwise, your signal is going to destroy， 它将会被摧毁掉，使它不够有足够的 whole time。也就是图里面，它这个呢要撑得够久，不能够太早被人家盖过去，被摧毁掉。
下面那个为什么是大于等
？OK， 这样会清楚一点。我们今天画这个图，网状代表就是我讯号不定，可能是1，可能是0，都无所谓。可是呢，我明确白部分就代表说，在这之前我就一定要确定一下要 stable， 不能改。This means you have to be stable. This means that it could be unstable. Fine, no problem. In other words, your data input should be arriving earlier than this time point, such that from now on you have stable value before edge and after edge. So much time. Before that, we call that setup time. After that, we call that hold time. After that time point, fine, you can change any data, no problem. In other words, you should keep right there. We don't want the next wave of the data catch up and override to destroy your data input in here. Is that clear? 我们清楚一点。Any question? So, in summary, what is that time? Sometimes it's time before the clock age. That data must be stable. The data should be arriving before the clock age, okay? And at least so much time. Not changing, okay? Stable, should be stable right there. Whole time is time after the clock age. That data must be stable. Even your clock age arrive, you still keep right there stable. So much time. We call that whole time. And then another term, the student uses, aperture time is the sum of set time and whole time. It should be clear. Set time and whole time, and this aperture time. TA is time around clock age. That data must be stable, including before cell time, including after the whole time. Right? Any question? Yes?
请问 TA 是上一个前面关系是那个上个加起来
大声一点。
，TA 的值
嘿
是代表是前上一个slide的那个关系式加起来的值。
，TA 就是这两个的时间的总和，也就是说我的开窗的意思。我不用讲开窗，因为我的资料必须在这个时间里面是维持稳定的。之前跟之后你怎么变动没有关系，可我一定要保证这段时间是不能变的。我的开 A 就会代表的前跟后一定要是稳定不变的，好，叫 aperture time。
就是稳定的时间。
对，它必须撑这么久的时间，不能够变动。OK， 那为什么在关于这一点？是因为什么样的情况之下你的set time不够？什么样的情况之下你的后time不够 ？What cases, what situation we don't have enough set time, we don't have enough whole time? What the situation? What the problem? For set time, the reason why you don't have enough setup time is because you don't give enough clock period. Or we can say that your computer delay going through the computer circuit is too long, such that it arrives after this. In that case, you don't have enough setup time. Right? You look at the circuit. If this delay is too long, then it appears the output later than we expected. And then you don't have enough setup time. Right? Because this clock edge is right there. You have to arrive at least so much time earlier than that. And if this computer circuit is too slow, then your output becomes stable later than our plan. And then you don't have enough start time. And we also concerned about hold time because we are worried about that the computer circuit, your shortage delay is too short, too small, such that after clock edge, the clock to Q, and then this delay is not long enough such that the new value will catch up with the old value and override the old value, such that the old value don't have enough hold time. In other words, we don't want that the new value will catch up. Then you will not have enough stable signal after the clock edge. And that would be the whole time failure. Any question? So based on I'm thinking if we should get into the detail of here. Because for clock-to-Q delay, there are actually two kinds of clock-to-Q delay. One is the PCQ, the other one is CCQ. Okay, maybe I just skip these two pages because I'm not sure that you can really understand furthermore. So, okay, in the midterm exam, I'm going to skip this page and this page. Okay. Try to make it simpler. You only have to understand these pages. That should be fine. That be right?
期中考后那2张不可能。
Any question? Okay, let's go back to the testing. 你回到上礼拜还没讲完的部分。We should be able to finish it, and that's going to be our coverage of the midterm exam up to Unit 3. I think we are around the number. Okay, let me simply review it. Okay, we mentioned that there are 3 kinds of testing. Yeah. The first one is logic verification. It's about design correctness. Your design, whether or not it's correct. So it's just like program debugging. Try to find any kind of bug to debug it. It's about logical error. And the second phase is debug time. The manufacturing debug. After you manufacture a chip, you get back the first chip. You want to look at the chip whether or not it really works. And sometimes, even though the logic verification, no problem at all, you still have some kind of electrical failure, electrical problem. Like not enough driving power, not enough driving capability. So even though the logic is totally correct, for example, you have a gate like this, and you are connecting a ladder, and now many gates. Okay? Although from logic point of view, they are totally correct, right? No problem at all from Boolean function point of view. However, because the output signal is not strong enough, it cannot drive so many gates. It cannot connect to so many gates because the driving capability is not enough. Meaning your voltage could drop because the load is too high, and that could cause a problem. That kind of problem should be found out after you get the chip. Only after you get the chip, you will know the real problem. Before you manufacture, you don't know, you really don't know. You can just guess or estimate, but you have to make sure after you get your chip back, first chip. After that, everything's okay. We manufacture the chip in volume, 大量生产. But in that case, you might have manufacturing defect. For example, some dust particle in the clean room, and that could destroy your wafer. Some area, some point. So shipping defective part is a problem. So manufacturing testing in the last phase. It is about logic verification. Try to do all kinds of simulation in your design phase to make sure that you get the correct design. Serial debug, like I said, there could be electrical failure even though the logic is totally correct, like crosstalk signal interference, that charge leakage or charge sharing, like transistor share ratio fading, the width and channel width and channel length ratio could be not good enough, not appropriate enough. And last one is manufacturing test. Every chip has to go through this stage to make sure that the chip really works. And that's related to the yield rate. How many percent you can get a good chip. In the long chip, the 40 chip, you have to throw it out. Okay? And it's very difficult to test the chip, especially for complex chip. And we assume some kind of full model to do the testing. And the most popular one is stack effort model, meaning we assume that the reason why a chip could fail, the defect is that some point is connected to VDD or connected to ground. This is a simple model, although it cannot cover every case, but the phenomenon should be look the same, look similar, and assuming that for model should be enough. Okay, assuming all failure could know to be stack A, 0 or 1, meaning shorted to ground or VDD. Not quite true, but was well in practice because the behavior should be the same, should be similar. And then in the end of the last class, we talked about this test example for the conventional circuit. Okay, let's take a break, we'll come back.
那你说我刚听的这个我听不懂。那你在讲什么？我都在写经验测试，然后这是逻辑测试，然后 feedback time。我只听得懂这个是就是晶圆制造之后，是大量制造之后会有缺陷。那这个
就是你拿到你的晶片的时候，你要看它会不会有什么电路特性的问题。
拿到晶片之后要看有没有
就是实际上会有什么问题，逻辑它不会有那些问题。
可是我放隔壁。
再讲一次，一模一样的话，我需要思考一下。
就是
我听得懂，但是我没办法。
我刚刚讲什么？
就是你
实际上拿到晶片之后，它会产生会有一些问题，要解决那些问题，电路上或者是什么。
哦，就接线硬体层面。
对，就是实体上会有。逻辑就是你的程式那些。
不美，会不会？这是哪里来的？哪里？啊，老师这，我就知道这是不能用。就奇怪，你们就从包包里面拿出来。
感觉他这里会考很多名词解释，完蛋了，去上厕所。
我在想，我是不是要买书吗？要买吗？不要吗？之前名词解释我是靠那个。
书了，太书了。要不用了。
我在买中医书啊，我就直接抄那中医说明书。